The increasing popularity of industrial Ethernet also has an impact on its individual subnets. The number of nodes, their physical size, and the degree of network interconnections are all growing. An unstructured network like that becomes more and more difficult to manage, and optimal usage of the resources is no longer provided. The situation can be compared with an office whose paper communication gets out of proportion. The paper traffic can be reduced by printing several messages on one sheet. Depending on the point of view, the viewer will only be shown one aspect. The digital equivalent of this are virtual local area networks, abbreviated as VLANs. In this software method, according to IEEE standard 802.1q, various virtual networks are installed on one physical network. Where the traffic of one network is invisible to the nodes of the other networks. These VLANs segment the network without separating it physically. This yields a disentanglement of data traffic, resulting in improved maintainability and more efficient usage. The assignment of the ports to the VLANs is normally configured in the switches themselves. This configuration is transparent, which means it is invisible to the end node. Generating the VLANs does not require changing the cabling or the hardware equipment. The switches assign the end nodes to different virtual networks. To be able to communicate with each other, the sender and receiver must be part of the same VLAN. In principle, the end nodes can be part of several VLANs at the same time. The assignment can be achieved in different ways. Static means the assignment is made via the port to which the end node has been connected. This is the method used for the scalance X switches, or dynamic via the MAC or IP address of the end node, or protocol-based by means of the type of the service directed via the port, such as voice over IP, FTP, or HTTP. VLANs are realized by supplementing the Ethernet telegram with a small data block, a so-called VLAN tag. This is a byte sequence in which one ID for the used VLAN and a priority level have been encoded. The application of VLANs leads to a separation of the data traffic of different networks on jointly used lines. Broadcast telegrams, for example, are no longer sent to all nodes, but only to nodes of a single VLAN, which reduces the network load. In the same way, faulty addressing and other faults also affect only one VLAN and not the entire installation. Finally, the hardware requirements are reduced as several VLANs can share the same components without interfering with each other. The logic structure of the networks becomes independent of the physical position of the end nodes. The ports of the switches to which end nodes are connected are also referred to as edges, connections between switches as trunks. The switches automatically inform each other by means of the GVRP protocol which VLANs can be accessed via the respective trunks. The configuration of the edges mostly occurs via web-based management, a user interface familiar from the Internet. Generally, switches insert the VLAN tags in telegrams which arrive via the edge ports and remove them from the telegrams which are delivered via edges. For port-based VLANs, the edges are configured separately for the input and output direction. The reason for this becomes evident when viewing the example of two PCs, which are part of two different VLANs, A and B, and which are both to access a printer. The printer receives jobs from VLAN A as well as from VLAN B. Since the switch removes the tags, the printer cannot know from which VLAN a job has come, since for the printer the VLAN configuration is completely transparent. In order to transmit the response of the printer to both PCs, a third VLAN X must be configured, which is used for tagging telegrams received from the printer before passing them on to the PCs. The X300 and X400 switches of the Scalance X device series are suitable for configuring VLANs. Their ports can be configured so they always accept telegrams which have already been tagged by the end node, or always dismiss them. This ensures a certain degree of protection from unauthorized access. A marker for the telegram priority is also embedded in the VLAN tag. Different classes of service ensure the preferred forwarding of high-priority telegrams, which benefits multimedia and voice transmission services as well as Profinet I/O. Port-based VLANs, for which the VLAN allocation is determined solely via the port of the end node at the switch, have advantages over dynamic and protocol-based VLANs. A failed node can simply be replaced by a new one, without having to change the settings of the MAC or IP address, for example. Furthermore, the same IP addresses can be assigned in different VLANs without resulting conflicts. This facilitates the configuration of identical or similar network cells, and fewer IP addresses are required. This is an advantage VLANs have over IP subnets. VLANs use the same physical network for several logic virtual networks. Various messages transferred via the same medium are only visible to the intended receiver group. The application of VLANs offers a number of advantages. It is a standardized method with high flexibility and simple configuration. Costs for cable and components are reduced. Instead of several separated networks, VLANs use a joint network infrastructure. Network load is reduced. Broadcasts are only forwarded within the VLAN. Prioritizing of telegrams. Low-priority data traffic no longer inhibits time-critical services. The possibility for unauthorized or unintended device access is reduced. Faulty addressing only influences the respective VLAN, but not the entire network. Simplified address assignment and multi-usage of IP addresses is possible. VLANs are the first choice for an efficient and hardware-saving configuration of extensive networks.